everyone. Welcome to another Reactor live stream. My name is Nadia and I'm really excited to be your host today. Before we dive into the main event, I'd just like to remind everyone about a Reactor code of conduct. Our aim is to cultivate a positive and inclusive environment for all our participants. So please, let's keep our interactions respectful and supportive. This evening, we are joined by MJ, who'll be taking us through binding vector databases with Azure Container Apps. So this is part 4 of the Let's Talk Vector series, and I will share the link to the other ones after this. Throughout this session, feel free to drop your questions in the chat and we'll do our best to address as many as possible. For those who want to revisit today's session, you can do so on our Reactor YouTube channel. Without further ado, let's give a virtual round of applause to our wonderful speaker. Hi, MJ.
Hey Nadia, thank you for introducing me. Yes, and again, very excited to have this 4th installment, for this Let's Talk Vector series. And this topic has been in my mind for quite some time now, and like as months go by, I'm having much more collective thoughts around it. Obviously getting much more experience around it as well. And the way I'm seeing it is that this topic is just keeps on evolving, right? And this is one of those times when I'm seeing that vectors are really materializing, properly. When I say that, like, it's not something that just kind of like a talk of town for 3 months, 5 months. Now it's becoming wider and wider, and like much more diverse set of approach, much more diverse set of technologies are happening everywhere. And yeah, that's why I'm very excited to always talk about this topic. For today, I'll be talking about Azure Container Apps in particular. I know we've talked about Azure Container Apps partially in the past, in a way that you can host a Docker container. In this case, things like Quadrant or other open source um, vector database can be hosted on Azure using Azure Container Apps. But this one's a bit different. This is kind of like purposely built vector databases, right? In the Azure point of view for developers while you're developing, right? Your application. Okay, so that's why you have to think of like this approach is more for developers, right? Um, so just a quick intro. Although we're not really gonna dig deep on Azure Container Apps itself, although I really love using this technology, right? The easiest way to explain Azure Container Apps to other people for me is just mention it's a simplified Kubernetes, right? So for those who came from the Azure background and is familiar within the Azure environment, you might have come from the app services capabilities, right? Like I do remember very vividly around 2011, 2012, novel idea in Visual Studio, right click, publish your solution, you get into a app service environment up and running. Fast forward to now, obviously there are like different types of applications. We've seen the whole emergence of this microservice architecture, this concept of containerization, and again, before Kubernetes became the default approach these days, there was a time around 2015, 2016, when the discussion was Kubernetes, Mesh OS, or Docker Swarm, and that throughout that time, technology has evolved again into what's now known Kubernetes. However, having worked with Kubernetes during my time around 2019 up to 2021-ish, even early 2022, that experiences have been very interesting. Wherein like you get the whole point of containers, you get the whole point of Kubernetes orchestration, but you need a team to do this, right? Like you're not it's a separate skill of its own, that someone like a developer who just wants to really work on projects very easily to get started, right? um, So that's why I think Azure Container Apps is really hitting that mark wherein it's a managed Kubernetes environment. Like you can deploy containers any kind of like runtime that you want. You want to have .NET apps in there, Python apps, Java, Go, so on and so forth, right? Like it's not very, you don't necessarily have that limit. Um, that's why again it's very developer friendly. And again, the key message here is that it's a containerized environment, right? Meaning you still need to follow a concept of containers. So that means you either use Docker registry, or if you're in Azure, obviously Azure Container Registry, right? So that's kind of like the idea in there, right? Like it's kind of like simplified um, environment for you. And one thing in particular that within the Azure Container Apps capability, they introduced this feature called services, or you can also call it add-ons. Yeah, but services is much more generic. But also, if you just a quick side note, if you do search for Azure Container Apps services, it's gonna conflict with the SEO of the app services. So just be mindful of that. So the Container Apps services itself is again the feature within the Azure Container Apps, right? So it's not Azure App Service. It's not its own thing. It's within the Azure Container Apps capability, right? So the point of services is that it's kind of like an add-on within your app, right? It's technically still a container, right, that you have to run in Kubernetes, right? But the idea is that they're meant to be data storage, and they're kind of like there for development purposes, so that most likely your app needs to be connected to a database, or in this case a vector database, and you want it to be simplified experience with your app connected to that data store without the whole setup of connection strings, authentications, managed identities, and it's all within that context of internal networking as well. So one of the really cool features of container apps is that capability of having that container environment to host multiple apps, multiple container apps within that environment. And that also includes the networking aspect of it. So in this case, this app services, right, this container app services, they don't have ingress. So what that means is that they're not publicly facing. So meaning if you add on these services, or if you spin this up, they're not meant to be accessed outside of the container apps environment. Okay, so that means if you spin up Postgres, it's not meant for you to use Azure Data Studio or pgadmin or DataGrip to connect to that environment. Okay, again, it's meant to serve within the context of the application. Okay, so that's kind of like the distinct aspect of it. Why that's very useful for many reasons, right? Again, if you're developing apps, and let's say you just need a Postgres database for testing, right, purposes, or you need a Postgres database that will be used across multiple apps within the Kubernetes environment. This is really a good pre-configured setup for you. Okay, that's why it's very powerful. And the magic as well with these container apps services is that it has this concept of bindings that would allow you that you're not exposing any keys, you're not exposing any kind of like even the host name itself, they're kind of like hidden, and they're all stored and shared within the OS or environment variable, okay, of container apps environment. So meaning you don't necessarily have to maintain the keys anymore. You can literally just talk to it as if it's a local host environment. like it's like local host. But if you come to think of it, it is localhost within the Kubernetes networking environment, right? So that's why that's going to work. So as of now, it currently supports different data store, and I purposely placed Quadrant, Postgres, Milvus, Weaviate as the first four because they're kind of like vector-ish, vector databases. And again, if you remember in the previous session, we talked about Postgres, where you can have a PG vector extension for that one to have um, the vector capabilities. However, I did look at it because the Postgres version in here in Container Apps Services is version 14. Version 14 does not come with the pre-installed PG vector. So unfortunately, it's not really one of the good environments for that setup at the moment. Yeah, Quadrant works and Weaviate as well. Kafka and MariaDB, although they are not really vector databases, they could be they could store vectors, right? And again, any storage can store vectors. But um, Kafka and Maria, they have a different capability around that, and um, they're not, in particular with Maria, they're not very similar with PG Vector at the moment or Postgres, and with Kafka, it's also a bit different. And then I actually forgot to add in the slides, but it also supports Redis. So with Redis, there is a vector capability as well with Redis, especially if you're working with LangChain. Redis is kind of like one of the most popular kind of like vector store, if you may, in that regards. All right, so let's get into it. Let me show you what this is. Okay, let me just open my Azure portal. All right, just give me 1 minute. Let me just open it real quick. All right, so okay, what I did is I had to log into the whole Azure portal and everything so that you don't have to see that anymore. All right, so I'm in here. I did create a resource group called RG Let's Talk Vectors. And within here, we do have a container apps environment and a couple of container apps. Okay, so think of it like this container apps environment is the one. Let me zoom in a little bit so it's easier to demo. Um, this container apps environment is kind of like that manage cluster for you. And this container app are containers that are running within that environment. So the analogy here is that the container apps environment can technically have as many container apps within it. Okay, so that's kind of like environment within environment. You can have many container apps. All right. So in here with this container apps environment, okay. Well, the thing is when you're setting this up, okay. One thing I just want to share is that if you're setting up Azure Container Apps from the portal, you have to build it in a way that you have to create the container apps, the app first. At the same time, you create the environment as well. So it's very similar to Azure App Service, where when you create a website, you have to create the app service plan as well, right? So it's kind of like that tandem that you have to do. But if you do this via the CLI, the Azure CLI in particular, you can create the container apps environment first before creating the container apps, which I prefer to do so that I can set up the environment properly first. And then the usual thing that you want to set up in your container apps environment is your workload profile. Um, like usually, especially if you want to create like dedicated workload profile, that would allow you to manage like okay how big or how small the cluster is. So that, but for this demo, I'm just using the consumption workload profile, which is like 4 vCPUs and 8 gigs of RAM. And within this container apps environment, that's where you set up, a bunch of different things. Something that's really interesting is this whole open telemetry endpoints that I didn't configure today, but again, it's very nice to have this. Um, and the other thing as well is this whole .NET Aspire dashboard would be a really good addition as well, so that you have a good visualization of all of your applications in one place. Okay, so now, all right. So within the container apps environment, the important bits would be the apps. Like these are the container apps within that environment. And if you can notice, is that why is there only one app in there? But when I go to the overview, I'm seeing many applications. The reason for that is that these other apps, they are called Springboard. So um, I'm not very familiar with the with the analogy of Springboard, but um, basically they're meant to be again like side by side with the container app itself. They're not meant to be a application of its own, right? So that's why their app type would be called Springboard. And the other one that you saw earlier that's the container app. All right. So now where do I create, these springboards? Or again, springboard services, add-ons, bindings. All right. So they're under here in services and preview. Okay. So this is where you can create this add-ons. All right. So you can configure. And by the way, there's also an upcoming feature for Java component. So I think that's where it got the Springboard analogy with the Spring framework. So with add-on, you can add things like Kafka, and then put in Kafka in there and just create that. Okay. So when you create this add-on, right, the thing that you have to be aware of is that you're literally just spinning up an instance of it. But in order for this to work, there's that dependency. Okay, now I'll show you that. There is that dependency. By the way, you need to refresh this as well. So come on. Where's my Kafka? All right. There you go. Ah, not yet. Okay, I mentioned that it might take a few seconds. We'll change the reflect. There you go. Yeah, Kafka is in there. So you would see that there's that connected apps in there, right? That's the most important bit, because if you click on something like let's say Kafka, and then if you look at trying to connect in there using containers, it's going to send an error. And again, this is going to save you a lot of time when doing this, because you know um, you need to bind it first to an application, so in order for it to be operationalized. Okay, so um, okay, there you go. So the way to bind that application, this service, okay, is that you have to go to the application itself that you want to bind it in. In this case, my application is Notebook. I'll explain this whole notebook thing later on. So when I go here, I have to go to the actual revisions and replicas, and I have to click on the name. Sorry, I have to go to the container itself, and if you see, I need to add the bindings in there, right? So I need to add the binding for that service so that I get past that error with application not bounded. So it's very easy. Click on edit and deploy. Um, Also, you can do this via the CLI. Then just continue with this one. Just skip to the binding part and just add on binding, add the Kafka one, connect, and finish, right? Like just continue with the whole process. So I'm not gonna do that. Just showed you how to do it. Okay, now first I'm gonna explain this notebook and what am I trying to achieve here. So for those who might be aware of or who's guessing, the reason why it's called okay, actually there's a good question. What are the key factors you should consider deciding between Azure App Service and Azure Container Apps? By Sagar. So for me, the most common um, s- um, differentiator for me is that if I'm having a multi-app scenario, or let's say multiple services, like I have like a backend in .NET, I have a backend in Java, I have a backend here, and like I still want them to talk to each other. That is, one of the good use case of container apps. The app service, on the other hand, is like everything is just like one, application in right that you want to host in there. Although app service supports containers as well, but again, it's a single container at the moment. I do know that Azure App Service supports the multi-container approach, but it's currently in preview. And I would suggest that if you're going to go to that route, go to the Azure Container Apps path instead. All right. So why is I'm going back here? Why is this like notebook, right? So because I came up with a very novel use case of this, right? Which is why can't I use container apps for notebooks so that my data engineers, developers, or data scientists would be happy, right? So I can spin up Jupyter notebooks quite easily, right? So that means I create this particular container app came from the Docker registry using the Jupyter SciPy notebook um, capability, all right, or sorry, image, right? So that means I can easily use this environment as a notebook, right? So this app is now a notebook environment. And then if you're getting where I'm going, those bindings that I created, I can just kind of like connect with them as if I'm connecting locally in my notebook environment. Okay, so that's a very solid use case for me for this approach, right? Like especially if you're experimenting with with vector databases in particular, like in Python in particular, this is a really good way to do it as well. And again, it's a shared environment, right? It's not like it's just MJ using this environment. So this is a shared environment. And again, this is going to be cheaper, or like it's a cheap environment in a way that it's serverless, it's managed Kubernetes, it's all kind of like very resource I guess resource efficient setup. Okay. So one thing though, for this to work, is that you have to make sure that you need to have only one replica, right? Otherwise, this is not gonna work. You need a different setup for that one. So why am I saying that? Because the session of the notebook is persisted into just that single replica. If you created multiple replicas, your notebook environment would kind of like get lost. Like, oh, you lost your session or something. But then there are different ways to approach that. I've worked with Spark for a long time now. There's a different setup for that, and that means you need to have a concept of like a zookeeper. Like so, you need to have a concept of like a one container that does the entry point, and then separate containers for, replicating the Jupyter environment. Okay, now let me. Okay, so this is the Jupyter environment. One thing that you probably want to do as well is you want to pass in the token in there. In this case, just random token, and then the target port that you want target is 8888, which is the default Jupyter notebook, Jupyter server port. And yeah, that's about it. And then bind all of these different resource out there, right? Quadrant, Postgres, Weaviate, Milvus, and Redis. Okay. Now, but one thing that you also wanna address here is that in Azure Container Apps, um, we have a concept of ingress. And again, this is a concept that's used in Kubernetes itself. So the easiest way to explain ingress is that, like the access, the external facing access of your application. So as I mentioned earlier, right? As I mentioned earlier, those services. Okay, let me just go back to some of them. For example, Quadrant, right? So Quadrant doesn't have ingress settings in here, right? Again, that's by default, right? Because it's a add-on, right? So you won't be able to publicly expose this, right? Um, so that's why the way it's gonna work is that this container app, this Springboard, this service, is not publicly facing. So um, the way to do that is that so that means that your application is the one that needs to be publicly facing. Okay, so that obviously you can still access that, right? But all those databases, um, all these bindings, they're all internal network, right? So you're not exposing any of them. So now let me go to the. Oh, actually, before that, let me just go to one of the bindings. In this case, like Quadrant, right? So for you to know if it's all good, you need to see that add-on is bound to application. Add-on is in running state, so that shows that it's ready to be used. By the way, these services as well, they have a lot. This getting started connecting to your app scenarios, such as if you want to connect with Node, .NET, Java, or Python. But the important bit that you want to see here is that you're getting that OS, that environment, right? If in Python in particular, so meaning you're not really exposing, right, the connection strings of this environment, right? Like so you can get them directly using the environment variables shared within the container apps environment. Okay. So again, very powerful, right? You don't need to set up a container, then create the key, manage the keys, so on and so forth. It's all kind of like managed and connected for you. By the way, this also works for .NET. So that environment, that get environment variables, is inherited already straight away. All right. So now let's go to that notebook. Sorry, before I go to the notebook again, one thing that I also want to explain is that in these services, right, these add-ons, you can also look at the log stream. Just go to the console so that you'll know if it's up and running, right? So like this is literally when spin up that container, you would see this in the Docker logs, right? So same is exposed in this log stream. So it's also just going to help you to know if your service is running or not. Really helps a lot. But what you can see here is that there's that dashboard, but that's not accessible. I mean, for Quadrant, and in this particular instance, it's not accessible because it's all internal network. But that means that port 6333 is being hosted, is assigned for Quadrant. All right, and there you go. Like I did some testing earlier. That's why we have those logs. All right, now let's go to the notebook. Okay, so with the notebook, I just have to go to the application URL. This application URL, again, because I have ingress settings, so this would be allowed and accessible throughout the internet. Okay, so I set this up to enable and accept traffic from everywhere. And then, just like I mentioned earlier, I'm exposing port 8888 so that it's, that's the default Jupyter Node server port, and exported that to HTTP. All right, so now if I go to the application itself, there. So this is my notebook environment. And if you run this for the first time, you need to pass in the token, and that's why it's recommended for you to set up that Jupyter token environment so that you can just use that as the token. All right, so now I have a Jupyter environment hosted on Container Apps, right? So you can see, you'll see that Azure Container Apps.io URL to kind of like show that, hey, it's in Container Apps. Right. Now, in here, okay, so you can create notebooks or run the console or even terminal and stuff like that. I already created a bunch of them. In particular, let's go at Quadrant. So just like pretty much any notebook environment, you can use this to do pip install. One thing to note though, with this pip install, because it's a single instance Jupyter server environment, this persists until you obviously restart the kernel, right? So that's why for versioning purposes, so that's why I just need to be aware of that one. Like some versions might have some conflicts as you go along. So typical pip install Quadrant client for Python, and then in here, okay, so you import that Quadrant client and see here. Let me just try to zoom in a little bit. All right. So in here, you would see that you can get these values directly from the Jupyter notebook, right? Again, directly from the Jupyter notebook. This Quadrant host and Quadrant port that we were mentioning here earlier, right? In here, they are accessible. They are accessible within that notebook environment. So what that means is that actually, if let me just comment this out. Right? If I do a print of this one, right, you would see that, hey, it's already named as Quadrant. But you see, it's not like your name. It already used the Quadrant host name within the environment, right? So it's a named host. It's not like an IP address, right? Or it's not like local host, right? So that's one good way to kind of like work on it as well. The reason why that's important is that you can have multiple quadrants, within that environments, right? And they would have different, host names as well. So that's why just need to be aware of that. So there you go. Let me just quickly try to connect, and there you go. Connection successful. All right. Then from there you can do the usual quadrant exploration that you want to do. List all collections, create a collection, literally just run this again. And yeah, it mentions that the sample collection already exists. So yeah, there you go. So this is a again an environment where you can play around with the manage quadrant for you. Um, Again, this is for you to take advantage of this, and at the same time, right? Like again, the key message here is that this is a shared environment, right? This is not your local PC, right? Or this not your local um, environment. So this means that other developers can also work on the same stuff, and then you work locally, and then you try to promote it using CI/CD. You get this to Azure Container Apps, and then you want to test your application if your vector use case is working. Um, so yeah, this is one of those use cases for that. There's a question from Alistair Rigney, and for production workloads. All right, so for production, um, this is subjective, right? My approach for production workloads is do not use this approach, services approach for production, for many reasons. One is that it's in preview. Second is that it doesn't really persist your data, and like the idea is to kind of like have that short-lived scenarios. Like the data that you'll be putting into these vector databases within services of container apps, they're meant for, again, development, right, and exploration. They're not meant for to be representative of the actual data of that business. So what that means is that the beauty of container apps though is that you can set different environment variables, right? That when you go to a production workload, and when you set up your whole environment in a CI/CD way, and hub and spoke model, and the whole kind of like multiple environment setup, you can spin up the actual production grade services out there. Let's say, for example, with Quadrant, right? Like you have many options. Like the probably the best options right now on Azure is to literally use Quadrant on Azure. Um, I'm still advocating Quadrant Cloud versus Quadrant managed by you, either on a VM or even in Kubernetes or even within container apps. I would still go with Quadrant Cloud for the reason of it's a managed cluster for you. So yeah, so in that production scenario, you would just change the environment variable to point to that. Right. Now, what else can I explore here? So I did try Milvus earlier. Um, this was working a couple of weeks ago, but this is where there's a drift in the versioning again of the client. Hence, when you try to connect here, right, it's not connecting properly. Um, but yes, you can see you can get that Milvus host and port as well. And it's a named host, right? Milvus and 19530 is the default port of Milvus. Yeah, so the idea is that yeah, you can have that hosted endpoint for you that you can kind of like work around with. This one, Postgres, this is what I was mentioning earlier. Because it doesn't because it doesn't because the version of Postgres. Let me just go here. So with services. So because the version of Postgres that was used here is image tag 14, right? So it doesn't come with PG Vector yet pre-installed. And again, unfortunately, there's no way to sideload the extension at the moment, at least what I know of. And here's the thing, right? It These services they are hosted in the mcr.microsoft.com registry. So they're not hosted on the Docker Hub. Again, that's a very important distinction as well, and note that you have to be aware of. All right, so that's why when I try to run this, yeah, like it can't find that extension, right? Because the extension doesn't exist in Postgres version 14. But what else is working? Weaviate is working. So I worked with the Weaviate project, by the way, like a couple of months ago, wherein we are doing some local inferencing of some image data and like barcode scanning and like trying to associate that to the most relevant product or items. So yeah, that's why it was a good experience with Weaviate. Um, yeah, there you go, right? Like in Weaviate, same thing. You just have to get the environment host. So Weaviate underscore host, Weaviate underscore port. Then in Weaviate, you use this concept of a URL. So you need to kind of like bind them as a URL. So with the Weaviate host and port, and then you need you click you connect to the client from that URL. So there you go. Like it that's the URL weaviate.8080, and we just check the server is ready. There's the is ready um, function within the client class that would allow you to see that. Yeah. Um, right. So with this, okay, that pretty much shows up a lot of this, capabilities, right? Now, I guess where can this really go, right? And what can be improved on this? Um, one is, if um, there are certain things that I kind of like want it to be added within this whole feature, knowing doing vectors for a while now. Um, Number one is I want the Cosmos DB one as well. Um, to be maybe it's not in this approach. All right. So within container apps, there's another feature that where it also might get confusing. So there's this service connector. Okay. This service connector is separate from the these add-ons that I just showed you earlier, right? So this is kind of like where you can quickly connect and set up the whole managed identity to that external services. Okay. So that means like if this container notebook, I want to connect to, let's say, yeah, Cosmos DB. Yeah. So then I have to go here and there, right? Um, I would like a very similar experience as well with like a short-lived kind of like Cosmos DB instance within that add-on capability, especially for vector purposes, and then an easier way to switch environment between that one and this one. So to answer, by the way, the other question as well about production workload, this is where you set up a proper production workload, right? Like, in your prod container environments, this where you set up the connection to, um, this different uh, service types. In particular, like Cache for Redis, they have this, right? Wherein before this services capability came in, this is how you would do it, right? Like you have to spin up an Azure cache for Redis, which, by the way, costs quite differently from the services option. And yeah, like that means you have to set up a dev Redis for that purposes. But yeah, what we just did earlier was that you can use a kind of like a dev Redis environment. But what I want is an easier way to also switch, or like a environmentalized capability to switch between this and that. Um, Other than that, there are also some things that I need. This concept of Dapper is very interesting. So it's a way to do the whole, reliable service to service calling. Um, yeah, and like doing that message, publish, subscribe. I think this is really powerful when you get this working with vectors, because that means that you can have a lot of capabilities, especially in the more real-time scenarios, like on-time chatting, on-time inference and stuff like that. Dapper would be really kind of like a key component for that one, because most of the vector use cases at the moment, in my exposure as well, is that it's always a post production data, or meaning it's like a final form data, in a way that you have to convert this final form document into vectors, right? Like you generate these PDFs, like they are final, right? Not like an on demand, you're still actively working on it type of like vector representation. So I think Dapper would be a really good way to bridge that inter containers inter services capability for that use case. Um, then the other bit as well is that I also like is that if I can also connect this to the Aspire dashboard, so that even though they are just kind of like short-lived apps or like add-ons, I also want them to be connected to the Aspire dashboard when that's ready in the future. I'm just not sure how that's gonna work. But um, what else? The Some of the things that I also want is that especially in Postgres versioning, like having the capability to choose which version of this specific add-ons would be really helpful. Um, that would be really great, because again, right, with PG Vector for Postgres, it's not available at 14. I believe it was available on 16 onwards, like natively. So yeah, there you go. Speaking of PG Vector and Postgres, they've now extended that capability as well to have that similar disk and capability from MongoDB and Azure Cosmos DB, NoSQL API. So that's why it's very interesting as well to stick with Postgres. Okay. All right. So the other bit as well that I also want is maybe an ingress capability for those um, add-ons as well. Although maybe a bit limited. Um, I get that it's needs to be binded to an app or something, but still having to use things like Data Grip or Data Studio would be really helpful for those scenarios. Um, yep. Other than that, I think I'm good for now with this topic. And again, this is all in preview, so have a try with this. And I think the key component that you want to look at is the Jupyter environment, which is in that Jupyter SCI PY notebook image that you want to use. And yeah, like there's a demo as well with using Quadrant with container apps, which uses the music store concept, but it's very similar to what I showed you. It still uses the whole notebook environment for that one. With that, I think that's it for now, Nadia. We'll close it in.
Awesome. Thank you for that, MJ. I just wanted to check if we've got any questions. We've got a couple that have come through. We did have a message come through from Alistair around serverless should be the default architecture, containers only for legacy. Another one we've got is, what are the key factors we should consider when deciding between Azure App Service and Azure Container Apps?
Yeah. I think I did answer this one already.
Oh, you did?
Earlier.
Okay.
Yeah. But again, just to recap, right? Like
Mhm.
Azure App Service is really good for those single app scenarios. Container apps is very good for like multiple app scenarios within that single environment.
Awesome. I think that's all we have got. I want to thank everyone for joining us today. The recording should be up on YouTube by tomorrow. And I want to say a big thank you to MJ as well for coming on to do this series. We will be taking a break in July and we'll be back in August on the next Let's Talk Vector series. So thank you all. Thanks, MJ. And
Thank
we'll
you.
see you all next time. Bye for
We'll
now.
see you next time. Bye for now.